Hi everyone, welcome to Vishwablooms. So in this video we will be looking at the vectors concept 1 class 8 physics techno. So this is the new chapter. So in the concept 1, as you all know, we will be having complete introduction. Okay. So in this concept we will be seeing about scalars. So we will see firstly about scalars, vectors and types. Okay, so that is what is there in the introduction. Very simple. Okay, don't get panic. So let's begin with this. First, physical quantities are divided into two. Okay, the classification is two types. First one will be scalar physical quantity and second one will be vector physical quantity. In simple words, scalar physical quantity is a quantity which has only magnitude, and vector physical quantity is a physical quantity which has both magnitude as well as direction. But this is not enough. We need a proper definition for this. So let us look at that proper definition. Scalar physical quantities are the physical quantities that will follow simple algebra. Okay. And vector physical quantities, these will follow vector law of addition. Okay, so this may be new to you, but don't worry, in upcoming concepts you will be doing additions, vector multiplications, everything. So you need not worry about this, but you should understand vectors will follow vector algebra, scalars will follow simple algebra. Okay, in your upcoming classes, like in your 11th and 12th, you will be having completely chapters on vectors both in mathematics and physics, so you need not worry. So basic idea is important. Okay, so first, in scalars, as I told, you will have only magnitude, but in vectors you will have both magnitude and direction. And scalar quantities are followed by a unit and they will follow simple algebra, and vectors will follow the vector law of addition. So this is the summarized part. Now let's look at some of the examples here, okay, for scalar and vector quantities respectively. First, for scalar physical quantities, if we take the examples, will be length, mass, time. Okay, all these quantities are scalar. So there are many, okay, many physical quantities. So I cannot write everything here, right? Now for the vector physical quantity, we will have many actually, but I'm giving few of the examples. Displacement, velocity, and many are there, okay, etc. Here speed will come in scalar, speed, in vector acceleration. Okay, in this way you can find many of them. Now how do we represent these physical quantities? That is the question. Now first I'll show the representation of scalar physical quantity. Scalar representation is very simple. Simply, if you are given mass some 15 kg, 15 kilograms, so kg you will write, that's it. So this is the magnitude and this is the unit, that's it. Magnitude followed by its unit is called a scalar. Very simple notation. Now we have to see the representation of a vector quantity separately because it is very important. A vector is denoted by using an alphabet overheaded with an arrow. Now if for example, if I take this is a physical quantity A, so if I put an arrow mark on top of it, it becomes a vector. That is the representation. Okay, now if A is the origin and B is the terminus, that means if A is origin like this, B is terminus in the sense end part, that's it, AB, then the vector will be represented as AB bar. That's it. Simple, right? Now we shall see the magnitude, how we will represent the magnitude of the vector in this way. Modulus, you will put it in modulus. So you read it as magnitude of A. Okay, magnitude of A. Now magnitude of a vector quantity is also a scalar quantity. Very important. Magnitude of a vector is also scalar only. Okay, now we shall move on to the types. There are many types, so we will look into all of that quickly. First we have like vectors, the vectors in which the in which the direction is same. See here, A vector, B vector and C vector, they are all moving in one direction. Okay, so what can you simply say? The vectors which have same direction, that's it. They are called as like vectors. Next we have unlike vectors, the vectors which are having mutually opposite directions. Okay, opposite direction. See here in the example also you can see A vector is in towards the right side and B is towards left side, opposite. Okay, this is about like and unlike. Now we shall look into the next one, that is coinitial vector. See, coinitial vector is nothing but the vector in which they have same origin or same initial point. See, initial point is O. From this point only everything is starting. So they have, what do they have in common? Same origin. That's it. Simple. They are called as coinitial vectors. Now we shall see coterminal. So the vectors in which they have same terminal point. That means see, two vectors are coming in this way and they are meeting at the same point. So same terminal point, same terminus. Okay. Now fifth one is collinear vectors. See, a vector parallel to straight line is called as collinear. See, now this is a vector and this is Ka. Why do we call it Ka bar? Means this is some part of A, not exactly the same magnitude, right? Some part of A. That's why we have written it as Ka. Simply you can tell it as parallel to straight line. They are called as collinear vectors. Now coplanar vectors, simply same plane. If the vectors are lying on the same plane, then they are called as coplanar vectors. See here, you can see this B and C vectors, they are lying on the same plane. This is the plane and they are lying in the same plane. Next we have negative vectors. Two vectors are said to be negative vectors if their magnitudes, that means their magnitudes are same. But the directions are different. See here, the magnitude of both these vectors is A only. Magnitude same, but the direction, if you observe, it is opposite direction. Okay, next equal vectors we shall see. Two vectors are said to be equal if they are having same magnitude and also same direction. That means see, magnitude of A is equal to magnitude of B equal to magnitude of C. Let it be some x. Okay, sorry, some x I am assuming. Okay, so that is what that means. The magnitude of three vectors is same and the direction is also same. Okay, next we shall see the null vector or zero vector. Null vector or zero vector simply implies that the vector whose origin and terminus point both are coincided. See, generally this is origin, this is the terminus point, right? So in this kind of vectors, the origin and the terminus point, it is coincided. That means in this way. Clear? So for these kind of vectors, the magnitude is 0 and direction we can't determine it. So can't be determined. The direction can't be determined. Next we have proper vector. A vector whose magnitude is not 0 is called as proper vector. Suppose, let me consider the vector as A, so that a magnitude is not equal to 0. That's it. Next we have position vectors. If you consider this Cartesian plane where you are having three axes, x-axis, y-axis and z-axis. So this z-axis, see, doesn't mean it is cross, okay? The axis which I cannot show it on paper or screen. So actually the z-axis will come on to your screens, will come up on the screen, okay? That is z-axis. So with respect to the origin, if the point is represented, that gives the position of the vector. Suppose this is a p vector here. Now the coordinates are given, right? That is given with respect to the origin, okay? It starts at the origin of coordinate system and terminates a point in coordinate system. Now if I have to write that p vector, how will I write? Simply x I bar plus y j bar j cap plus z k cap. Cap or bar you can put, but yeah, I'll explain this later also. Don't need to worry. This will come in the upcoming classes, this part. So don't worry about this. Simply we have to understand the position vector, that's it. Okay. And I hope you understood this position, P position. Okay. Now we have to see unit vector, the last type. So in unit vector, the magnitude of the vector is 1, only 1. And it is denoted as a cap. Suppose the vector is a, then it is denoted as a cap. The cap denotes that it is a unit vector. You should be very mindful of that. Now how do you represent a unit vector in the direction of a? In the direction of a bar. That means a cap equal to a bar by magnitude of a bar. That's it. Now I have told in the direction. You may be thinking in opposite direction, then what will be the value? Opposite direction, simply the negative value will be the answer. That means this a cap in the opposite direction will be minus of a bar by magnitude of a bar. That's it. Clear? So these were the types and also introduction on the topic. Okay, now look at the clarity achiever. First question. The direction of null vector. Just now we have seen the point. I'll show you here. A null vector, the direction cannot be determined, right? So the answer will be cannot be determined and it's B. Okay. Second one, we have a matching. Okay. Now matching coplanar vectors. So coplanar vectors, just now we have seen they lie on same plane. So S will be the answer for A. I'll write it here. S. Co-initial, they have same initial point. Co-terminal, they have same terminal point. Co-linear, they have parallel straight line. So SPQR, check in the option SPQR, it's option A. Okay. Next we have statement type of question. The physical quantity which do not follow simple algebra are vectors. See, vectors, they do not follow simple algebra doesn't mean they are vectors. Vectors follow vectors law of addition. So it is a wrong statement. B. Physical quantities which follow simple algebra are vectors. No, they are actually scalars. And here if it is scalars, then this statement is correct. Right? So option would be B. Both are false, right? Okay. Fourth one. Among the following, the quantity which is not scalar, actually options are given as 5 meters, 10 kg, 3 meter due east and 4 seconds. See, for a scalar quantity, we should have magnitude and unit. That's it. Enough. MU format. But for A, C, D, it is like that. Sorry, A, B, D. I'm sorry. A, B, D. For this, additionally, the direction is mentioned. So, that is not necessary for a scalar quantity. It is a vector quantity. So, not a scalar means they are asking for a vector. So, answer is C simply. Fourth one, answer C. Now we shall look at the fifth one, which is a assertion reasoning type question. Assertion says that speed is a scalar quantity. Yes, that is absolutely correct. Next, reason states that speed does not follow vector addition, vector law of addition. So yeah, that is also correct only, but the explanation is not so clear. Okay, it does not follow vector law, does not give proper reason, so it is B. They could have given it follows simple algebra, then it is perfect reason. Okay. Sixth one, among the following physical quantities, the quantities that depend on orientation of frame of reference is R. Okay. So generally, which of the quantities, those quantities which depend on frame of reference would be vectors, a component of vectors only. Okay, so the answer would be vector and a component of vector. B and D, vector and component of vector. And the other options were Scalar and magnitude of vector. See, magnitude of vector cannot be the option because just now we discussed magnitude of a vector is a scalar. So that is not in the option. That's why we are eliminating that. Okay. Now, seventh question we shall see. Among the following a vector physical quantity. First, that quantities I will write it here. Energy, power, force, mass. Okay. See, energy is force dot displacement, that is dot product. Okay, you will get to know about this in the last concept. Don't need to worry. So it is a scalar quantity. Power is energy by time. So it is also a scalar because scalar by scalar. Scalar only. Next, force. Force is like it is a vector because force has a formula. So next, force is mass into acceleration. Mass is a scalar but acceleration is vector, so the quantity will be a vector quantity only. Next we have mass. Mass is a scalar quantity as we all know. So the answer to this question will be force, clearly, right? Force is the answer. Option would be C. Next we have eighth question. Among the following, again scalar they are asking. So first option is displacement. Next, electric field, acceleration and work. See, work just now I told it is a scalar, so simply that is the answer. Displacement is a vector, electric field is also a vector, and acceleration just now as we discussed it's also a vector. So the correct answer would be D, work. Okay, next, ninth question. Among the following quantity which is not a vector, that means they are asking for a scalar quantity. First is torque. So torque is a vector quantity. Next, displacement is also a vector quantity. Velocity, vector quantity. Speed is a scalar quantity. So the answer to this question is speed, option D. Okay. Next, we shall see the silver package. Among the following, the false statement. First is look at the statement 1. The statement states that a vector has only magnitude but a scalar has both magnitude and direction. Ulta, first statement itself is a false statement. Next, B. Distance is a scalar quantity but displacement is a vector quantity. True. Momentum, force, torque are vector quantities. True. Mass, speed and energy are scalar quantities. That is also true. So they are asking for the false statement. So A is the answer. A is the answer. Next, second question, assertion and reasoning type of model. Assertion, a physical quantity cannot be called a vector if its magnitude is 0. Oh my god, absolutely wrong, because we have a null vector which defines that, right? It is against this, so it's wrong. Reason, a vector has both magnitude and direction. Yeah, that is correct. So option D, A is right and R is wrong. Next, again, assertion and reasoning model. Third question. Assertion states that two vectors are said to be like vectors if they have same direction but different magnitude. Yeah, absolutely correct. Next, reason. A vector always has fixed direction. No, vectors has different directions. Okay, that's wrong. Again, option is C here. Now, fourth question. The forces which meet at one point but their line of action do not lie in one plane, they are called as. Okay. First and foremost thing, read the question slowly. The forces which meet at one point, they are meeting at one point finally. Okay. And they do not lie in one plane. First main thing, read this part. They do not lie in one plane. Do not lie in one plane. That implies that they are non-coplanar. Non-coplanar. Okay. And they meet at one point. So they are concurrent forces. Concurrent forces. Simple, right? So option is B. Next, we have assertion and reasoning model of question, where assertion states that a null vector is a vector whose magnitude is 0 and direction is arbitrary. So see, null vector, simply we have seen that the magnitude is 0 and direction is not defined. So not defined, arbitrary, both means same. So assertion is correct, and reason, null vector does not exist, absolutely wrong. So option D, sorry, option C. A is right, R is wrong, right? Yeah, option C. Sixth one is a statement type of question. Statement A, all the like vectors are coplanar vectors. No, that need not be. Okay, all like vectors need not lie in single plane. Okay. Statement B, the magnitude of equal vectors is same. Correct. So option B, which states that A is false and B is true. Next we have passage, seventh question. First, they have given some passage based on the introduction points. Okay, you can read that. Next, first one, a physical quantity that follows simple algebra, scalar physical quantity, no need to think of that, right? Next, second one, among the following the example of vector physical quantity. Let's look at the options and answer in order to do this. First, mass, speed, displacement and length. See, mass and length, simply we can say they are scalars, eliminate them. Next, speed is also scalar, so displacement is only the vector quantity. So option will be C for second one, displacement. Next, C, third question, a vector physical quantity. So four options are given. First, A option states that it follows vector law of addition. B option states that it has both magnitude and direction. C option states that it follows simple algebra, and D states that it has both A and B. So D will be correct because it has both, follows the vector law of addition, and it has both magnitude and direction. Simple algebra is followed by scalar physical quantities but not vector physical quantities. Next, fourth bit, among the following a unit vector is. So actually, for finding the magnitude of a vector, we need to know this formula. In this concept, actually it is not discussed, but we found a question, right? Among the following a unit vector is. So for getting to know whether it is a unit vector or not, we need to use this. Okay. See, if a vector is represented as a I cap plus b j cap plus c k cap, the magnitude of the particular vector will be the square root of the squares, sum of the squares of them individual numbers, the magnitude part. Okay, so I'll show this. Okay, don't need to worry, with options we will see everything. Just note down this formula because we need to know this for the particular question. Only this question we are supposed to do with that formula. Without the formula we can't do. So we are supposed to find the unit vectors here. Okay, first A is I cap plus j cap. So how do we find the magnitude for this? Root of, here nothing is there, implies it is 1 square plus 1 square, where j nothing, so 0 square. So 1 square plus 1 square is 2, so root 2, it is not a unit vector, so A is wrong, cancel it out. Next, B is cos theta I cap minus sin theta j cap. Now find out the magnitude for this. It is going to be cos square theta plus sin square theta. Now cos square theta plus sin square theta is 1, so it is a unit vector, B is correct. For C, sin theta I cap plus 2 cos theta j cap. Similarly, like this only we are supposed to do. Okay, if you put 2 here, it will be 4. So I'll show it in the next slide. So take it as root of sin square theta plus 2 cos theta whole square. This is nothing but root of sin square theta plus 4 cos square theta. So I think we cannot get a unit vector. We cannot get this. Okay. Next, D, 1 by root 3 of I cap plus j cap. So 1 by root 3, you need to keep it in that way only. You are supposed to find this magnitude. Okay. So I bar dot j bar, in the first one only we found, it is root 2 magnitude. Okay. So 1 by 3 into root 3 is root 2 by 3, but it is not a unit vector. So the correct option is B. Okay. Next we will see the fifth question. The unit vector in the direction of A, the vector is given to us 5 bar equal to 5 I cap plus j cap minus 2 k cap. So how do we find unit vector in the direction of a given vector? The formula just now I have given. So a cap equal to a bar by magnitude of a bar. First find the magnitude of a bar in the method which I told you earlier for the previous question. So 5 square plus 1 square, here minus 2 you should take it, don't forget. Okay, if you don't take it also there is no problem because we are squaring the terms. Okay, now this will be 25 plus 1 plus 4. Okay, or 29 plus 1 root 30. Now a cap will be equal to, what is a bar given to us, just write the same thing here, plus j minus 2k cap and just divided by root 30. That's it. We are with the option. So option A is the right answer. So with this, concept 1 is completed. So do like, share and subscribe to Vishwablooms. Thanks for watching. Bye bye.